Hey everyone, today is May 19th, 2020. This is MJ. So far in the video series, we have gone through the introduction, right? And the prerequisite for this course. Prerequisite being three. The first one was the Unix OS. Second one was little bit of Java followed by SQL concepts. So from this video onwards we will start actually what we are going to go through the course, right? So from this video we will see HDFS, then in future we will go through what do you mean by Apache Scoop, followed by Apache Pig, then Hive. After that, next step is Apache Uzi, and we will see how we can evolve from this list. So let me start off with HDFS, and some of the things that we will go through this in this topic is we will see what do you mean by a block. Then I'll introduce you to name node, data node, secondary name node. Then we will see what do you mean by heartbeat, and how actually reads and write are in HDFS. So read operation, write operation. I think this is all theoretical concepts that I am writing right now. We will see why HDFS is called a warm architecture, which stands for write once, read many times. We will see what is a rack and what is the replica placement, or what's a replica. And once we go through all these theoretical concepts, the meat of this topic is HDFS command. So we will go through those HDFS commands in details. And I will try to stress more on HDFS command rather than these theoretical concepts. So I think with the time constraint, I'll keep this video related to only these points. And starting next video, we will see how HDFS commands are, and how they are different from the Unix command. So if you wanna get a head start, you can go through all the Unix command videos that we have in this playlist, so that you will have some kind of a refresh for getting started with HDFS command. So let me start off with the basics. So first of all, HDFS, what it stands for. Hopefully you know by now it stands for Hadoop Distributed File System. So I'll just write FS. Now the reason it is called HDFS because the HDFS is based on a framework, and that framework is called Hadoop, and it is distributed in nature. What I mean by that, let's say this is my laptop screen and I have Hadoop installed on it. So I can interact with this machine in such a way that it will give me feeling that it's a single machine, right? I can write anything, so it will be a single machine. But in the back end, there might be hundreds and thousands of machines which are connected together either logically or physically. By logically, I mean they are connected over Wi-Fi. By physically, I mean they are connected by an Ethernet cable. So that means they can talk to each other, they can communicate to each other, they can share information to each other. It doesn't matter whether they are connected logically or physically. So in the back end, you see all these systems are distributed across the globe, but you don't get that feeling, and that's the magic of distributed file system. So that's why it is called Hadoop Distributed File System. The advantage of distributed file system is that you can multiply the resources that you have for a single system using just adding a new node. This particular single machine is called a node. So let's say it has 1 GB of RAM and 100 GB of hard disk, then the entire clusters become 6 GB of RAM and 600 GB of hard disk. And this system that you are using to interact with this, it will give you a feeling that this machine of mine which has Hadoop in it, this acts as like 6 GB RAM system and 600 GB storage capacity system. So that's how the distributed systems are constructed. Tomorrow, if you need more storage power or more performance, you can just bring one more system or node in the network, and this will become 7 GB and 700 GB. So that's how it works. So when we introduce these many systems in the network, some of those systems or all those systems play very important role. So the most important of them all is called name node, which is also known as master node. The reason it is called master because HDFS follows a master slave architecture. So I'll just write it as MS. What I mean by that is name node takes care of all the metadata information, and it takes care of all the record keeping, or it knows whether a particular machine is on or not, whether a particular machine is running low on resources or storage capacity, something like that. So if the name node goes down, it is called as the entire system goes down, and that's why name node is also known as SPOF, which stands for single point of failure. So this was one of the drawbacks of earlier Hadoop versions, but that drawback has been overcome with something called as secondary name node, which is also known as SNN. I get confused with SNN and SSN. So SNN is secondary name node, which is an exact replica of a name node, but this is always active, the actual name node, and this is always in standby mode. So as soon as the active name node goes down, the secondary name node becomes active name node, and the name node which went down become a secondary name node. So the next question is, how do they make sure that there is a smooth transition between name node and secondary name node? So they share a file that is called as FS image. This file has the capabilities to store all the metadata information of the entire cluster. So I will write metadata of cluster, which means if you have access to FS image, that means you know which file is present in what data node, and which data node is running low on resources and whatnot. That brings us to my third point, which is data node. So data node's only job is to store data. As the name itself indicates, they store data, they help name node update the information of the data, and they help name node communicate all the information that they store. And they share this information with a mechanism called heartbeat. So heartbeat is a communication protocol. If you have done your computer engineering, you will know there is something called as RPC, which is nothing but a remote procedure call. So the way remote procedure call works is, since it is master slave architecture, there is a remote machine and there is local machine. So this remote machine has the capability to execute a process or method on the local machine. That's why it's called remote procedure call. I'm keeping everything really high level, so please don't quote me on that. I can go in details in like other playlists, but this is just for information, so I'm keeping it really high level. So this heartbeat is shared between name node and this heartbeat is shared between data node and name node, and then name node shares this heartbeat with secondary name node, and secondary name node does that vice versa, so that the FS image that you have at name node is always kept updated. This is very important. If your FS image file is not updated with every heartbeat, then you lose some important information to keep in that metadata, right? Other things that I like to touch upon is what do you mean by block. So a block, so let's say if I have a computer with Hadoop installed on it, as soon as I say Hadoop, that means HDFS will also be a part of that system. So let's say this is the hard disk of that system, and let's assume that the entire hard disk is dedicated for Hadoop. So this hard disk will have some logical partition in which you will store the data. So let's say I created a file abc.txt with size, let's say 200 MB. So the way this file gets stored in HDFS is, first of all, HDFS has these logical partitions. The size of each partition is either 64 MB or 128 MB depending upon the installation flavor that you have. So we will go with 128 MB because that's the latest one. So each block is worth 128 MB here, so you can calculate 128 MB multiplied by 9 and you'll get the size. So the way this 200 MB file is stored here is, first of all, it is splitted into chunk of 128 MBs. So the first chunk will be 128 MB, then the remaining, which is 200 minus 128, which is 72, second chunk will be 72 MB. So now I told you, right, data node stores the data, but it is name node's job to tell data node where to store the data. So you wanna create this file, you take this 200 MB, you go to name node will tell you to take this 128 MB and store here. So this is 128 MB, so this block is gone. Now name node again tells you take this 72 MB and store it here, because these blocks are going to be used for some other purposes, so you store here. But you don't store you take the entire block, but you store only 72 MB of data. That means you still have some storage available. Exactly talking about 56 MB. So 56 MB is unused, but 72 MB is used. Now data node takes this information and goes to name node, and name node updates the FS image file saying this file abc.txt, which is of 200 MB, is splitted into two blocks. One block is 128 MB stored here, and the other block is 72 MB, which is stored here, right? So this is how it works, and this is how the blocks are constructed in HDFS. Again, I'm going really fast with a broad definition in mind, but you can always get in touch if you want me to dive into details for this. Now the second the second one that I wanna touch upon here is Replica. Since we know the way data is stored in HDFS is like this, we have something called as Replica. And what I mean by that is, for explaining Replica, I'll have to explain what I mean by rack too, because that's how data center looks like. So let's say this is my building where I have where I have all the racks that are considered shoe rack, right? but instead of shoe there are servers or machines or data nodes. So this will be my first rack and this is my second rack. So I will call it as rack 1 and rack 2. So this is my data node 1, data node 2, data node 3, 4, 5, 6. It doesn't matter how many racks each data node it doesn't matter how many data nodes each rack has, and it's no rule that each rack must have same number of data nodes. It can have data node 7 too. Okay, so now the way Replica works is you take this 200 MB file and you split it into two parts because our block size is 128 MB, and you don't actually replicate the file but you replicate the blocks. So you take this 128 MB block, you go to data node goes to name node, and name node tells data node to store. Name node tells the procedure called to store this 128 MB in data node 2, which is in rack 1. So you keep the 128 MB here, right? But then the replica placement kicks in. It is called as replica placement policy. So according to this policy, the original block is kept here. Now usually this is replica placement policy is associated with replication factor RF. I will write here replication factor, and the default value of this replication factor when you install Hadoop is 3. That means there will be 3 replica of the original block. So the first replica, according to this policy, the first replica of the original block is in the same rack but in different data node. So this is my original replica. This will be my first replica. This is my original block. This will be my first replica. So I will call it as replica 1. Now the replica placement policy says the second replica should be on the different rack in a different data node. So I will choose at random D, and all this information is given to me by name node. So this is my replica 2. And the replica placement policy says the third replica should be on the same rack as the replica 2 but on different data nodes. So name node tells me to go to data node 6. So this will be my third replica. Now the advantage of replica placement policy is that if I pull a plug on rack 1, that means this entire rack goes down. And one thing that I forgot to tell you, heartbeat is shared every 7 seconds. So after 7 seconds, name node will know that this data node is down, this data node is down. So it will update its FS image file for this data node to be this data node. So whenever you try to access this 200 MB file and 128 MB block, instead of going here and here, it will directly go here. If for some reason I pull a plug on only this data node, this rack is still alive but this data node, then again after 7 seconds, name node will know that this data node is down, this is also down, this is also down. So it will update its FS image file with the address for this 128 MB block to be this replica 3. So this replica 3 will become the original file and rest of it will go down. And in the meantime, it will also trigger a replica call which will replicate this this block, since rest of the 3 blocks are down and it doesn't want to lose that data. So it's very complicated and very detailed and thorough process. I had to quickly cover it in the interest of time, but do reach out to me with your question. I'll be happy to answer them, and I'll be happy to explain it in more detail because I did not cover most of it. I'm passionate about it and would like to talk for hours about this topic. So, to recap, I know I didn't cover a few things because I did not find them that important. We went through all this topic except warm. Maybe in future I will cover it, but yes, I'm glad I could cover most of it that I wrote in the beginning of this video. So starting next video, we will look at all the HDFS command, and I'll again recommend checking out all the SQL videos in this playlist. That will be useful for you guys so that you will have a refresh mindset before actually going into this video. So thank you so much. Hopefully you had fun. Like, comment, share, subscribe. And I couldn't get a chance because of work to upload these videos. I'll try to be regular, but work has been extremely busy. So take care. This is MJ signing off. See you again. Bye bye.